Good morning, good afternoon, good evening, good night. In this video, we will work through the illustration of constructing a box plot on slide 49 of lecture set number 2. To improve the value of this example, I am going to replace the maximum value of 100 with a value of 160. So we're going to work off 160 instead of 100. A box plot is a visual representation of the 5-number summary. The 5-number summary is composed of the minimum value, the first quartile, the second quartile, which is the median, the third quartile, and the max. Okay. So our starting point will be just to fill out the 5-number summary. The minimum and the maximum are obvious. They are 12 and 160. We can see why this is true, given that the data is already ordered from smallest to largest value for us before we even started the problem. Now, to find the median and the quartiles, the first thing we'll do is determine how many observations we have. All right, so we're simply counting the number of observations in the data set. All right, so we have 12 values. The median is the value that splits the data into 2 equal halves. Okay, so the median is going to be located right here. Okay. So between the 6th and the 7th observation, recall that if we are working with an even numbered data set, so a data set where there's an even number of observations, the median will always be in between the 2 midpoints of that data set, or the 2 middle observations in that data set. So in the case of 12, between the 6th and the 7th value. All right, so that means that the median is going to be the average of 62 and 69, which is 65.5. All right, now Q1 is the median of the lower half of the data. When we are working with an even number of observations, we take strictly the values below the median. Okay, so when we're finding Q1, we are only considering the values below the median. And when we're finding Q3, we will only consider the values above the median. In the case that we are working with an odd number of observations, we would take the median with us in that calculation. All right, so Q1 is the median of the lower half. So that's going to be between the 3rd and the 4th observation. Since we have 6 observations in the lower half, which again is an even number. Okay, so this means that Q1 is 31 plus 42 over 2, which is 36.5. Right. Q3 will be the midpoint of the upper half. Again, we have an even number of observations, 6 observations. So the midpoint will be between the 3rd and the 4th observation in the upper half, which is the 9th and the 10th observation in the complete data set. Right. So that means that Q3 is the midpoint of 81 and 87, which is 84. So this is our 5-number summary. When we are constructing a box plot, the first thing we can do is actually mark down Q1, Q2, and Q3. Those values will always be marked on any box plot, regardless of whether or not outliers are present. So at this stage, if we wanted to, we could construct our axis and we could mark down the location of those 3 values. Before I do that, I'm going to compute the rules to check for outliers. Okay, so this can be the second step or the third step, depending on how you want to approach your box plot construction. Okay. So we will call these outlier rules. All right, so to determine if outliers are present in the data set, we have two rules. One rule for the lower half and one rule for the upper half. In the lower half, we take Q1 and we subtract 1.5 multiplied by the IQR. Good. Okay, so this means that we have to compute the IQR. So the IQR is simply the difference between Q3 and Q1. Okay, so that's going to be 84 minus 36.5, which is equal to 47.5. All right, so this is going to be 36.5 minus 1.5 times 47.5, which is equal to negative 34.75. All right, in our data set, there is no value that is smaller than negative 34.75. So this means that we have no lower tail outlier. Right. Now, we do the same thing in the upper tail, except our rule changes to account for the fact that we are in the upper tail. So the upper tail rule is Q3 plus 1.5 times the IQR. So that's going to be 84 plus 1.5 times 47.5, which is equal to 155.25. Right. Now we can see that our maximum value 160 is greater than 155.25. That means that we will flag the maximum value as an outlier. All right. Okay, so how does this affect construction of the box plot? Again, the three quartiles are consistent regardless of whether or not outliers are present. The detection of this outlier will only influence how the upper tail of the box plot is sketched. So the first thing we'll do is we'll build an axis to use for our box plot. Box plots can be drawn vertically or horizontally. Okay, there's no there's no better way. One way is not better than the other. I'll draw it horizontally for this illustration. All right, so this is my axis here. I'm going to have to mark down some tick points on the axis. Okay, so I'm going to try and run this from 10 up until 160. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160. Okay, now what I will do is build the mid part of the box plot, so the box. I'm going to mark down my the value of Q1, which is 36.5. So that's going to be roughly right about here, maybe slightly to the right, just a bit above the midpoint. Now I'll mark down Q2, which is 65.5. That'll be right here in the midpoint. And then I'll mark down Q3, which is 84. So that'll be right here. Right? And then I will connect these 3 points. Okay, so this is the box. Now, to construct the rule and the outlier, for the lower tail, we did not detect any outlying point. So our marker goes to the minimum value in the data set. Okay, so our mark point here, the tail or the whisker, is going to be at the minimum. Okay, so this is the min, which is equal to 12. Okay, and then this again is Q1, Q2, Q3. All right, so if there's no outliers, or if there are no outliers, the minimum and the maximum values are the minimum and the maximum from the data set. So those are the whiskers. In the upper tail, we have an outlying point. So what we do in this case is we mark the whisker at the value of our outlier rule. So we take this value, 155.25, and we mark that down. So that's going to be right about here. Okay. All right, now, and then this again is the rule, which is 155.25. And then what we do is we mark down the individual outlier at its value. So our outlier is a value of 160. So we can just put a circle here or a dot or a star, whatever label you want to use. It doesn't matter. And then this value is the maximum, which is 160. Okay, so that's how you construct a box plot. Now, what does the box plot tell us about the data set? Well, since a box plot is essentially just a representation of the quartiles of a particular distribution, one of the main things that we can determine is the symmetry or the skewness of the distribution by looking at how far each of the markers are from one another. For example, we can see that Q2 is almost right at the midpoint of the box, but it's just very slightly to the right. So this implies that there's a little bit of skewness in the data set. So the values are pushing a little bit more to the positive side. Okay. So since Q2 is a bit closer to Q3 in value, this indicates, or sorry, this indicates a little bit of left skewness. I had that backwards. Sorry. So if Q2 and Q1 are closer together and Q3 is further away, that would be right skewness. In this case, Q2 is a little bit closer to Q3 than it is to Q1, so that's left skewness. But in the overall image, we can see that the maximum point and our outlier rule is very far away from Q3, whereas Q1 and the minimum are much closer together. So in the overall picture, we're observing right skewness, because what is happening is the larger values are much further away from the bulk of the observations, and that's the definition of right skewness. Okay, so but then we can say, since the maximum or the max is much further from Q3 than the min is from Q1, the distribution will be right skewed. Okay. So it's a little bit contradicting in how I wrote it, but essentially in between the first, second, and third quartile, we have a little bit of left skewness. But Q2 is actually quite close to the middle, so we have it's a tiny bit of left skewness, almost symmetrical within the 3 mid quartiles. But in the overall image of the data set, because the maximum value and that upper whisker are much further from the box than the minimum is, the distribution would appear to be right skewed if we were to look at a histogram of this particular data set. All right, so as always, if you have any questions, please let me know.